So in this video here, we're going to take a look at some insights into model evaluation and also fine tuning. So if you have your own data set, you want to apply it on a computer vision use case. So we go in, take our data set, we can train a model on it, and then we're going to talk about how we can evaluate that model because we need to make sure that we have the best model before we deploy it into production. So we have a couple of steps that we can go in and do. We have some high parameter tuning, need to specify and test out different variations of our model, could be small, nano, medium model. Just do evaluation to see how it performs on our classes. We have some different metrics with the intersection over union, mean error position, and so on that we're normally taking a look at. So we're just going to dive into it and talk about the model evaluation and also fine-tuning aspect of a computer vision model. So let's just jump straight into the Ultralytics documentation. We have a bunch of guides in here, pretty much videos covering all of it, at least the most important parts for now. So if you go inside of it, we can see we have this insights on model evaluation and also fine-tuning, the induction. We already went over that. And first of all, we can have like a confidence score. So pretty much whatever task we're doing, we get a confidence score out. How confident is our model at the predictions that it's doing? So this is very important when we're looking at how accurate is our model, both when we want to detect classes, but also just in general. So we have the confidence score. It's a value between 0 and 1, basically just 0 to 100%. We also have the intersection over union, which basically just means how is our bounding boxes overlapping, could be our segmentation mask, bounding boxes and so on, how much are they overlapping on the ground truth data. So we need to have our data set with our labels. So if we're just taking a bounding box, we have our data set, draw labels around our objects, and then we want our models to predict that exact label on new data that hasn't been trained on before. So this is the intersection over union, the high intersection over union we have. This is also a value between 0 and 1. We basically wanted to have it as close as possible to 0 because that means we have a perfect overlapping bounding box. Then we have a mean error position, which is basically just across all the object classes that we have in our data set. So we are just looking at the mean across all the classes. We take the average of our position, and then we can do it at different confidence intervals, or basically like our intersection over union threshold. So when you're training our own YOLO11 model, whatever model that we're training in AI, for object detection and basically also for instance segmentation, we look at the mean error position of 0.5. So that means a intersection threshold over 0.5, but we can also take it in intervals and just take the average of that. So that will be from 0.5 to 0.95. So if we basically just set an intersection or union threshold at 0.95, that's going to be a very accurate model. So we have a bunch of different ways that we can go in and improve our models once we go in and do model evaluation, because we can't just take our data set, train one model and then use that in production. We need to make sure that we have the best model available, and we're also using that. So if we just take a look at 3 ways to improve the mean error position. First of all, we need to have good data quality. If you want to improve the model, it's basically just data quality. So if you don't have any good data, you won't get any good results. It's basically just trash in is also trash out from AI models, not just for object detection, computer vision, but for all models in general. Then we can do algorithm optimization. We can tune some different high parameters. We can test out different models, variations, and so on. And then we also have the annotation process improvement. So it could be that you have good data, but your annotation process is not good. You don't have perfectly bounding boxes around your object, segmentation mask and so on can be refined. So all of these ways are basically good ways to improve the mean error position and your model in general. So let's now say that we have trained a YOLO11 model. We can also go in and evaluate the performance of that, just to use an example. So we can also test out different image sizes. Could be that you want to detect smaller objects depending on the inference speed that you want to run at as well. So you can test out different image sizes, 640, 1280, and all of that, but also just how we can go in and access the YOLO11 metrics. So after training, we have a run directory. We will get all the different graphs, all of that stuff. We show that in the other videos. We also go over like all the performance metrics and so on and explain those in details. But this is pretty much just how we can extract every single metric. If you want to do your own visualizations, want to use them for tables, comparison tables, and so on to evaluate your model, that's a pretty good way as well. So when we're fine-tuning a model, we basically just take a pre-trained one. We can also build our own model from scratch. So we have different high parameters that we use for both cases. So for example, if we're fine-tuning our own model, we can start with a higher learning rate, and then it will just decay over time. So we learn less and less. With a higher learning rate, that basically just means that we take larger steps, at least in the beginning. So we want to do that when we're fine-tuning our own model, because we have a pre-trained model on a specific data set, and then we want to start fine-tuning it on our own custom data set. So we want to learn a lot of features from our new custom data set in the start and then decrease that over time so it learns less and less. Some other stuff that we're going to do for fine-tuning could be like tiling windows. We have videos covering Saji, how you can have a tiling window just running across your image. This will increase the accuracy significantly for smaller objects, but also reduce the inference time. So all of these different things here, like, you need to take those into account when you want to do model evaluation and also fine tune your own models. They go hand in hand. We can't just train one model, but with Ultralytics, like, you can train 3, 4, 5 models pretty much at the same time, but also just go in and evaluate them. If you just have the model instance, you can just call .eval and it's going to make the evaluation on your own custom data set. We can also do benchmarking if you want to benchmark it on your specific hardware and so on. And then we pretty much have a whole model evaluation phase. Make sure that you make comparisons and so on, because the first model might not be the best one, and also different parameters can affect it. If you're just talking about a few percentage difference in the accuracy, that's going to make a huge difference out in the real world. So I hope you learned a ton from this video here. Definitely go in and check it out. Make sure that you use these tips and tricks when you do your own model evaluation and also the comparisons. Hope to see you guys in one of the upcoming videos. Until then, happy learning.